Hi everyone. For 7.2, we're going to keep talking about solving systems of equations, but we're going to learn how to do it what is called algebraically, meaning using the equations instead of using graphs like we did in 7.1. There's a couple ways to do it, a couple methods, and the first one we're going to learn is substitution. Substitution means you're going to take one of the two equations, doesn't matter which one, you're going to solve it for either variable. You can either make it say x equals something or y equals something. And then once you've done that, you substitute that equation into the other one, and you'll solve the new equation. Now, a good time to use substitution is if at least one of the equations is in slope-intercept form, because slope-intercept form is y equals mx plus b, so it's already in y equals form. If you take that equation part, that mx plus b part, substitute it into the other equation for its y, then what happens is you've eliminated the y and you can solve for x. Now, after you have done that, so let's use my example from before. Let's say we substitute mx plus b, whatever the numbers are, we solve for the new x and we get x equals 3. Well, what you then do is you take that 3, you go back to either equation from the system. It actually doesn't matter which one you use. You substitute 3 for x, and then you solve for y. So like I said, it doesn't matter which one you do. You can solve for x and then substitute for y, or you can solve for y and then substitute for x. But what you do is you eliminate one variable using substitution, solve, then plug that one back in and find the other. So let's try one out. Here we have a system of equations, kind of like the ones we saw in 7.1, but we are not going to solve it by graphing it. What I'm going to do instead is I'm going to solve it by substitution. So I look at my two equations and I notice the second one is in y equals form, which means it tells me what y equals. So y equals this thing right here. Y equals negative 2x plus 3. Well, what I'm going to do, if that's y, I'm going to put it right here into the other equation for its y. That's what we mean by substitution. If one of the equations tells you y equals this expression, take that expression, put it into the other equation for its y. So if I do that, I'm going to start by recopying that top equation, 2x minus 5y equals 45, except instead of the y, I'm going to put the negative 2x plus 3. So what I would have is 2x minus 5. Now, instead of the y, I'm going to put the negative 2x plus 3. I'm substituting an expression for y. And then everything else is the same, equals 45. So that's the substitution part. Now, by substituting, if you look at my new equation, the one that's written in light blue there, there's no more y, there's only x. And because of that, we can solve for x. So that's what I want to do next. If I want to solve for x, the first thing I'm going to do, let's leave the 2x. I'm going to take this, I'm going to take that minus 5 and think of it as a negative 5 and distribute it. So I have negative 5 times negative 2x, that would be positive 10x. And then I have negative 5 times 3 would be negative 15. And it's still equal to 45. So right here, and I could have done this at the beginning, let's say I put in my dotted line here to remind myself. This is my equation that I'm solving. The first thing I have is like terms. I have a 2x plus 10x on the same side of the equal sign. Let's just add them together. That would give me 12x. Now I'm ready to solve. The first thing I want to get rid of is the 15. So I add 15 to both sides. Cancel that one out. I get 12x equals 60. And then I finish by dividing by 12 to cancel that out. And what I did is I solved for x. What I figured out is that x equals 60 divided by 12, which would be 5. Now that's basically half of my answer. Because remember, to answer this question, we need both an x and a y. So what I said is after you find one thing, we just found x, I can go back to my original two equations, pick either one of them, substitute 5 for x, and solve for y. Now, I'm going to pick the bottom equation. Because it's in y equals form, it's much easier to substitute a number right here for this x and just, do the work. 2 times that number plus 3 is the answer. If I substitute the x up here, it'll work. It's fine, I can do that. But then when I plug in x, I still have extra work. I have to do this to both sides and add that and multiply and divide. So the bottom one's probably easier. So I'm going to take the bottom equation, and I am going to substitute 5 for x right here. So I'll have y equals -2 times 5 plus 3, or y equals, -2 times 5 would be -10, and -10 plus 3 is -7. So those two things together are my final answer. X is 5 and y is -7. The way I'm going to write my answer is as a point though. So remember, every point is x comma y. X is 5, y is -7. So the point 5 comma -7 is my answer. And in light blue was the substitution work. I substituted one equation into the other, and then I solved for x. We got x is 5. In purple, I did the second half of the question. I plugged my answer in to find the y, and then in red is my final answer. It's the two things, the x and the y together, written as a point. Now, what I want to do to wrap up the notes today, it's actually a good review of what we did in 7.1. Let's solve this exact same system by graphing and see if these two lines do cross at the point 5 comma -7. That would be a good test for us. Okay, so here are our same system of equations, same two equations. Let's solve by graphing this time and see if we get that same point. I'm going to do the easy one first. I'm going to do the slope-intercept form, the bottom one. So for the bottom one, the y-intercept is +3. That would be here. The slope is -2. That would be down 2 and over 1 would be here. Let me plot a couple more points using slope. Just keep going down 2 over 1. That makes it easier for me to draw on the line because sometimes it's hard on the computer screen. I want it to be nice and accurate. And then for the second line, or I guess for the first line, the top equation, we will do, we could do intercepts, but we're going to get a really big number, so that might not work that well for us. Let's try this another way. Let's take that top equation, 2x minus 5y equals 45, and let's put it into slope-intercept form. Let's subtract 2x from both sides. To cancel that out, would give me -5y equals, we'll put the -2x in front and the +45 on the end. And then we'll divide everything by -5. And we'll have y equals, that'll end up being +2/5 x. Negative divided by negative is positive. We'll leave the 2 over 5. And then this will be a minus because it's positive divided by negative, and you'll have a 9, which is a little bit off of our graph. I can kind of imagine it down here at the bottom. But the y-intercept is going to be way down here at -9, and then it's going to be up 2 over 5. It's going to hit at that point right there. So we had a little trouble squeezing it in. But it looks like the point where they cross is that point right at the bottom of the graph. Now, if you remember our answer from the last slide when we did this algebraically by substitution, it was the point +5, -7. That's the exact point where those two lines are crossing. So by taking our example and doing it by substitution, which is what's new for today, and then by also doing it by graphing, it's doing a couple things. Number one, it's checking your answer and saying, yeah, I did it right. I'm getting the same answer both ways. But it's also proving that these are both ways to solve a system of equations. You can do it by substitution. You can do it by graphing. We're getting the same answer either way, so it's two different ways of doing the same problem. Okay, let's do one last system. This time what you notice is neither one of them is in y equals form. But I want us to solve it by substitution. So I'm going to do this. I'm going to take one of the two equations. Remember, I said this in the notes. The first step in the notes was to solve one of the equations for either x or y. Now what I think I would do is take the bottom equation and solve it for x. And the reason I picked that is because the x is already by itself. If I pick the top equation and solve for x, I have to add 2y to both sides, and then I have to divide by 3, and I get fractions. I don't want fractions. What I want to do is, in one step, take this bottom equation, subtract 4y from both sides to cancel this out, and get x equals, we'll call it negative 4y plus 8. Now that I know what x equals, I can take that thing and I can go back here and substitute it for x right there. So let's do that work. Just like we did in the first example now. I have 3x, but instead of x, I'm going to do 3 times negative 4y plus 8. Now that I know it's what I boxed up there. Now that I know that's my x. And then I have minus 2y equals 10. And we'll solve this one for y this time. So I'm going to distribute the 3. I have a negative 12y. That would be plus 24, 3 times 8. And then a minus 2y equals 10. I'm going to combine my like terms. The negative 2y and the negative 12y gives me negative 14y plus 24 equals 10. We will subtract 24 from each side. Let's see if I can squeeze this in here. Cancel that out. We have negative 14y equals negative 14. And when we divide by negative 14, we end up with y equals 1. Negative 14 divided by negative 14 is positive 1. So the first part of my answer is y equals 1. Now that we know y equals 1, remember you can pick either equation, doesn't matter which one, and substitute 1 for y. Now this one kind of doesn't matter. I would probably use the bottom equation again, but you can do either one. So let's take that bottom one. Let's take the x plus 4y equals 8, and we will substitute our answer, which is 1, for y. So I have x plus 4 times 1 equals 8, which would be x plus 4 times 1 is 4. Now if I subtract 4 from each side, I got my answer. X equals 4. 8 minus 4 is 4. So my final answer is a point. The x goes first, that was 4. The y goes second, that was 1. My final answer is the point 4, 1. And I'm not going to redo this one by graphing. We did that once just to show it works, but if you wanted to check your work, you could graph these two equations and show that yes, they do cross at the point 4, 1.